Hello there once again. Thank you so very much for joining us. I'm still Hamza and I'm going to take you through mathematics again. We are going to integrals type 5. And this type 5 of integrals, we are going to see what we call the Tan substitution. The Tan substitution technique, whereby we are going to see integrals of the kind. If you see an integral of this kind, of a squared plus b squared of x squared, it has no root, it has an addition sign, it has a quadratic x in it, and it's in the denominator, then we are good to use the Tan substitution technique. In this case, we are expected to do the following. So you will let a squared plus b squared x squared be equal to a squared plus a squared tan squared of theta. If yes, you can subtract off the a squared, and therefore bx squared is going to be equal to a squared tan squared theta. Therefore the bx is ideally a tan of theta. For that reason, you will see that b over a of x is actually tan of theta, and therefore b, actually dx, when you differentiate, will be a over b sec squared of theta d theta. That's the derivative of tan of x. It is sec squared. Once you have recognized that, if you come back here, this is the same as a squared into 1 plus tan squared theta. But always 1 plus tan squared theta is sec what? Sec squared theta. So instead of having this or that, one can straight away substitute this as a squared sec squared theta for a squared plus b squared x squared, which is in the denominator. So when I substitute, I'll have integral of 1 out of a squared sec squared of theta times dx, which is a over b sec squared of theta d theta. Remember, I told you in substitution, don't allow the x to come back because you are removing it. So this becomes sec squared, can be divided by that. This a alone can divide off with that a. My result would be 1 over ab, the integral with respect to theta, which is the same as 1 over ab integral of d theta, and the answer is 1 over ab of theta plus a what? A constant. Now, in totality, if I want to write this as the final expression, remember you have to bring back x. So to bring back the x, we shall say, what was x? What was theta? Theta can be got from here. Bx is equal to a tan of theta. Therefore, theta is tan arc of bx out of a. So the integral of 1 over a squared plus b squared x squared with respect to x is going to be 1 out of the product of the two constants whose roots have been got times tan theta, which tan theta is tan inverse of bx out of a plus a constant. So this is a general definition of the integral of 1 out of a squared plus b squared plus x squared. And this type of technique, we are saying we are using what we call the Tan substitution, which is integration type 4. With that, we can take a look at some examples on this. Of course, I said it's not always in good order for people to always cram through the box which I've designed. Better you know how the procedure is, how to let, how to substitute, how to get the root, how to differentiate, then you can make your substitution a general aspect. So allow me to take you through example 1. So example 1. Example 1 is going to be the integral of 1 out of 5 plus x squared dx. Integrate. Firstly, we let 5 plus x squared be equal to 5 plus 5 tan of theta. So that you lose the 5 by subtraction. Then x squared is 5 tan squared of theta. It is from this note that x alone will be the square root of 5 tan of theta. When I differentiate, I'll get dx is equal to root of 5 sec squared of theta, having differentiated this with respect to theta. Now we are good to substitute. When I substitute up here, what will I have? I'll have the following. The integral of 1 over 5 plus x squared dx is now going to be the integral of 1 out of 5 plus 5 tan squared of theta d theta, which is actually the d theta is supposed to be dx, but the d theta is root of 5 times sec squared of theta d theta. Now remember, if I factorize out the 5, I'll have 5 into 1 plus tan squared of theta. It is the integral we are looking for, times root of 5 sec squared of theta d theta. But sec squared theta and tan squared theta from trig definitions are the same. So I can lose this with that one. So I'll have 1 over 5 times root 5. If I rationalize this root 5 by dividing by root 5 d theta, then I integrate, I'll lose this root 5 with that 5. So I'll end up having 1 over root 5 times theta plus a constant. Then come back to where you had the square root found. It is from there that you can make theta the subject. So therefore, the integral of 1 over 5 plus x squared dx is going to be equal to 1 over root of 5. Theta can be made the subject here by saying it's tan arc of 1 over root of 5 of x plus a constant, and that will become our solution for the integral of 5 plus x squared, which is in the denominator. Okay. Remember, if you have a challenge of missing out some point or some explanation somewhere, always review the video again. You can view the video once again. You can share it to your colleagues, to your friends, to your students. If you're a teacher, if you're a parent and you know your student, your child is studying some of these things, you can share the link to them, and they can also have an opportunity to enjoy the class of integration. Example number 2, we have the integral from 1 over 3 plus 4x to the square dx. With this, we have limits, so it's a definite integral, and we want to integrate it from root 3 over 2 to 3 over 2. In this case, we have to do the following. One, we let 3 plus 4x to the square be equal to 3 plus 3 tan to the square of theta. This is the same as thrice sec squared of theta. But when you lose the 3 with this 3, you'll end up having 4x squared is equal to 3 tan squared theta. So therefore x is root 3 out of 2 of tan theta. And therefore dx will be root of 3 over 2 sec squared theta d theta. Then if I want to convert the limits, remember we had x, we had theta. X was root 3 over 2 to thrice over 2. Come and substitute right here where you have x is that. When x is root 3, you get a 1. Tan inverse of a 1 is pi by 4, which is 45 degrees. When I substitute here root 3 over 2, I'll get 3 over root 3. is tan theta. But 3 over root 3 is the same as root 3, which root 3 is tan by 3, pi by 3, which is 30 degrees. So you get the inverse of that, which is 30 degrees. So I have the limits, I have the substitution variables, so I can integrate. So I'll have integral from pi by 4. Okay. Sorry, this is supposed to be pi by 3 is not 30, it's 60. So it's tan inverse of 60, or tan inverse of root 3, which is 60. So it is from 45 to 60, which is pi by 3. So if it's pi by 3, we are good to go. When you substitute down here, I'll have 1 over 3 sec squared of theta times dx. Dx is going to be root 3 over 2 sec squared of theta d theta. I can lose the sec squared. Then this is going to become root 3 over 6 of theta, integrable from pi by 4 to pi by 6. When I substitute, I'll have root 3 over 6 into pi, sorry, this is pi by 3 minus pi by 4. From that note, you realize the following. Root 3 divided by 6 into 4 pi minus 3 pi divided by 12. It is from this that you'll have the final answer as pi times root 3 divided by 72. If I rationalize this, it will become pi over 24 root of 3 as the answer. So you can always confirm with the calculator and proceed and see how best you can have these answers. So the sec squared was lost by division. The root 3 over 2 multiplied divided by the 3, realize the 6, and then when you simplify, algebra will take you to that solution. Example 3 says integral of 1 over 2x squared So we have another type of illustration here. Now this one is not obvious like the previous ones. It also calls for the method of completing squares. And in this case, you let 2x squared plus 4x plus 11. You can factor out the 2 and you have x squared plus 2x plus 11 over 2. When you simplify this, you realize twice of x to the square plus 2x, half the linear term here, 1, square it, subtract by itself, plus 11 over 2. You realize a 2 of x plus 1 squared plus, this is 5.5 minus 1. You will get 4.5, which is 9 over 2. So therefore, this is the same as what? This is the same as 9 plus 2 into x plus 1 to the square. So this has now come out as the question, or as the definition is predicting. Substitute it up there. You have integral of 1 over 9 plus 2 into x plus 1 squared dx is the question. So relate 9 plus 2 of x plus 1 squared is equal to 9 plus 9 tan squared of theta. If yes, we shall have the following. This is the same as 9 sec squared of theta, and likewise root of 2 into x plus 1 is equal to tan of theta. Therefore, root of 2 into x plus 1, if I differentiate this, I'll get dx. Root of 2 of dx is equal to sec squared of theta d theta. So when I substitute, I'll have integral of 1 over 9 sec squared of theta times root of 2. So it times sec squared of theta, the theta divided by root of 2. I can lose the sec squared, then I'll have the answer as 1 over 9 root of 2 of theta plus a constant. Now this was not a definite integral, so it doesn't have limits. So in general, the solution will become integral of 1 out of 2x squared plus 4x plus 11 dx. The answer is going to be 1 over 9 root of 2. The theta can be got from here. Theta is tan inverse of root of 2 into x plus 1 plus a constant. And that will be your solution. So allow me give example 4 as the assignment. 1 over 3 plus 10 x to the square dx. My followers, our learners, our subscribers, please try out that number. You leave the answer in the comment section. In case you get a challenge, let us know, and then we find a way of how we can assist. I'm still Hamza Rwama, and I'm still inviting all those who need one-on-one sessions of coaching, both in physics and math. You can always step in and see how we can help you, ranging from all countries that are English speaking to our own country, beloved part of Africa, which is Uganda. So for those of you Ugandans, even if you're up country and you need a class, a Zoom class, a one-on-one, a group class, we can always arrange and see that you can have such classes. Thank you for joining all our videos. Thank you for joining and subscribing to all our channels. May God bless you about that. And please keep it up here. Share the video, like it, encourage your friends to always come through and watch the videos. Have a good day.